Okay, so number 4, square root x plus y plus square root of x minus y plus square root of x minus y minus the square root of x plus y prime all equals 0, where x is greater than 0. So you can kind of tell just by looking at it that it's homogeneous just because everything is in the square root. So we're going to test that and set f of x comma y equal to f of t of x comma ty. So we're going to substitute all the x's for tx and all the y's for ty and see if there's an alpha that's all the same. So we're going to get the square root of t x plus ty plus square root of tx minus ty plus tx minus ty minus tx plus ty. So y prime equals 0. You can factor out a t out of every single one, so it's going to be t to the 1/2 square root x plus y plus t to the 1/2 square root x minus y plus t to the 1/2 square root x minus y minus t to the 1/2 x plus y. So alpha is 1/2 because you can factor out t to the 1/2 out of everything. So now we confirm that it's homogeneous. Now we can go ahead and use the homogeneous differential equation method. So we're going to move this part over, get the y prime by itself. So it's going to be the square root of x minus y minus x plus y, square root of x plus y, y prime equals negative square root x plus y plus square root x minus y. So we just subtracted this side to that. Okay, so divide this by both sides, so we'll get the y prime by itself. So y prime is going to equal negative x plus y plus square root x minus y over square root x minus y minus x plus y. Okay, so now I'm going to divide everything on the inside by an x. So it's going to be, just to make it easier when we substitute for v, so y equals to negative square root of x over x plus y over x plus square root of x over x minus y over x over square root of x over x minus y over x minus square root of x over x plus y over x. Okay, so that simplifies to negative square root 1 plus y over x plus square root 1 minus y over x over square root 1 minus y over x minus square root 1 plus y over x. Okay, so now from here we're going to set so y is equal to vx, therefore v equals y over x, and y prime prime. So we can substitute all the y's and y prime for v, or all the y over x for v. So v plus xv prime equals negative square root 1 plus v plus square root 1 minus v over square root 1 minus v minus square root 1 plus v. Okay, so now taking this, we're going to multiply it by a value of 1. So we're going to multiply all of this by square root 1 minus v plus square root 1 plus v over square root 1 minus v plus square root 1 plus v. So that the bottoms, we get rid of the square roots on the bottom. That's why we do that. So v plus x v prime is equal to, now just a lot of algebra. So after you do all that algebra and factor, you're going to get v plus xv prime equals negative 2 plus 2 square root 1 minus v times square root 1 plus v over negative 2v, which is equal to, dividing by, or canceling the 2's on all of them, equals 1 plus square root 1 minus v times square root 1 plus v over negative, or actually positive v, because negative, these two negatives cancel, so it's positive. Okay, so now we're going to subtract this v over to this side, so it's going to be x v prime is equal to 1 plus square root 1 minus v times square root 1 plus v, and I'm going to go ahead and just add it, or just subtract it here, because when you subtract it over, it's going to be minus v squared over v. So minus v squared all over v. Now multiplying this v to that side, we get v x v prime equals 1 plus square root 1 minus v square root 1 plus v minus v squared. Divide this whole quantity to the other side, so it's going to be, and divide this side by x and this side by x. So it's going to be v times v prime all over 1 plus square root 1 plus v square root 1 minus v squared equals 1 over x. And since v prime is dv over dx, this is dx, since you multiply it, and this is dv. So now you can integrate both sides. I'm going to add a new paper. It's the integral of v over 1. I'm going to go ahead and put the minus v squared there, plus, and I'm going to 1 minus v squared dv equals the integral of 1 over x dx.